Hi, welcome back. Tim for Volt Lighting. Today we want to discuss a little bit about how to choose the correct transformer for your project. Now as you go through the website, it can be a little difficult and sometimes a little confusing about which transformer to choose. Now don't be afraid. Today we're going to help you navigate through that and choose the right transformer for your project.
As you look through our website, you're going to notice that we have 5 different sizes of transformers available. One of the most common questions we're asked is the 1200 watt transformer more powerful than the 75 watt transformer? And if so, which one do I really need to buy? To begin answering these questions, let's look at a typical transformer in a little bit more detail. To the right you see a picture of a 900 watt transformer. Now the easiest way you can tell that this is a 900 watt unit is simply by counting the number of circuit breaker switches it has inside, which in this case is 3. All of Volt's transformers, with the exception of the 75 watt unit, are 300 watt transformers. Now to clarify, our 900 watt transformer is simply nothing more than 3 individually breaker protected transformers stacked side by side in one case. When asking if one transformer size is more powerful than another, there is one very important thing to know about a transformer. The rated size of a transformer has nothing to do with how powerful it is. To illustrate this point, let's turn to the computer world. It's fairly common knowledge that a computer with 300 gigabytes of memory is not necessarily faster or more powerful than a computer with 900 gigabytes of memory. The term gigabyte is a unit of measurement which describes the capacity these memory cards have for storing data. For a 900 gigabyte computer, you may have 3 300 gigabyte memory cards on one motherboard. That would make this a 900 gigabyte computer. So you may own a computer with a ton of memory, but the size of a computer, or rather its storage capacity, really has nothing to do with how powerful the computer is. That boils down to the central processing unit. Now we can look at our transformer in much the same way we did the computer. We have 3 individual 300 watt units that make up a 900 watt transformer. Just like our 900 gigabyte computer was no more powerful or faster than the 300 gigabyte computer, our 900 watt transformer is also no more powerful than a 300 watt transformer. If you remember, the rated size of a transformer has nothing to do with how powerful it is. The greater size of the transformer simply means that we can put more lights or more wattage on this bigger transformer. Looking at our transformer, you can see that we have 3 300 watt transformers stacked side by side, which make up our 900 watt unit. Each of these 300 watt transformers is also individually protected with its own circuit breaker. Each internal transformer will also have its own associated common, shown down below in the screw terminals. Looking inside this transformer, we can see the layout and how the circuits refer to each of the commons. The switches will refer back down to common 1, to circuit 1, common 2, to circuit 2, common 3 to circuit 3. Each one of these internal transformers is wired to its associated common. By stacking all 3 of these 300 watt transformers side by side, that gives us 900 watts of usable capacity for lighting. When speaking of how powerful a transformer actually is, we have to look at the voltage outputs of the transformer. All of the Volt Pro transformers have variable voltage outputs between 12 volts and 22 volts. The higher voltage taps allow us to overcome rapid voltage drop, which is a common problem in low voltage systems. For this tutorial, however, we are only covering choosing the right size transformer based on its wattage capacity. Before we get into covering how to size a transformer that's right for your project, we first need to cover the 80% rule. Now the 80% rule is a rule we use in landscape lighting to dictate the size of the transformer that you're going to need for your project. The National Electrical Code states that transformer loading, which is the watts used, should not exceed 80% of the rated capacity of that unit. In other words, when we add up all the watts of the bulbs and the lights we're using, it should never exceed 80% of the total rated capacity of that transformer. As an example, if we have a 300 watt transformer, if we were to add up all the wattage of all of our bulbs that we're using in our lights, we should never exceed 240 watts, which is 80% of the 300 watt load. The reason for this is that there is actually a component of wattage or load from the power simply having to overcome resistance as it travels through the wire. In some cases, this can be as much as 20% of the total load. Exceeding these limits puts your transformer in a dangerous situation. The National Electrical Code further states that circuit and branch loads, which is the total watts per home run cable, this should not exceed 80% of the rated capacity of the cable. The most common type of landscape cable is 12-2, and it's rated for 240 watts worth of load. Now, you should never use more than 80%, which is 192 watts. If you begin to exceed that, your wire will get very hot and potentially could melt. To know what size of transformer to purchase for your project, you must start out with a basic lighting design. Now this design should spell out what you want to light, how many fixtures will be required, and what the wattage of the bulbs are you plan to use in each fixture. As an example, we're going to look at figuring the size of a transformer needed for a halogen system. The three colored wires you see represent 3 home runs that run from our transformer to the fixtures. To begin our calculations, let's say for example on the yellow run we would like to softly illuminate 2 big stone urns that are on either side of a sidewalk. We're going to use 2 Gentle Splash floodlights with 20-watt bulbs. This gives us 40 watts on that home run. On the green run, there are 2 trees on either side of that same sidewalk that we are going to cross light. The 4 tank spotlights we are going to use are going to require 35-watt lamps, which is going to give us a total of 140 watts on that green home run. Finally, we know we need light to illuminate the length of this sidewalk. We're going to use 5 7-inch China hat path lights to illuminate this walkway. Each of these will have a 20-watt lamp, which will give us a total of 100 watts on the red home run. At the top of the page, we have totaled up all of our lamp wattage, which comes to 280 watts. Now this is where the 80% rule becomes of paramount importance, because most folks and even many contractors would see 280 watts and mistakenly settle on a 300-watt transformer. Since their total watts are under the 300-watt rated capacity of the transformer, they falsely assume that they are good to go. What most folks fail to do next is multiply the total watts times 1.2. This will show that there is potentially a consumption of 56 watts just in wire resistance. When we add up our total wattage plus 20% potential resistance consumption, it leaves us with a total load of 336 watts. Well, this is well over the 300-watt rated capacity of the transformer. To use a 300-watt unit on this system would simply be asking for trouble. For this system, you're going to want to choose a 600-watt transformer at your time of purchase. Now let's look at the same design example another way. This time we'll be using the much more energy efficient LED lamps. Instead of 40 watts on the yellow run, we'll only be using 6 watts. For the spotlight on the trees, 20 watts instead of 140, and on the pathway lights, 15 watts instead of 100. Add up our total at the top of the page, add 20%, and we have our total estimated watts consumed. The choices for the LED installation could be either our 75-watt transformer or even our 300-watt transformer if you plan to add on at a later date. If you're wanting to use the digital astrotimer in your transformer, you'll have to choose the 300-watt unit or something larger. The astrotimer is not compatible with our 75-watt unit.
Alright, well that'll conclude our segment on how to choose and size a correct transformer for your project. Just don't forget the 80% rule and you'll stay out of trouble. Thanks again for joining us. We'll see you next time. If you have any questions, please contact us at voltlighting.com. Thanks.